So, should everyone learn how to use trig ratios, guys, to find missing sides and angles on a right triangle? Okay. So, let's start off with some steps on how to do that. Okay, so you're going to be starting off with a triangle. Okay, now you guys don't need to draw the triangle here because we're going to do some examples in a minute. I just want the steps to make sense as we're going. So let's say we have that. So the first thing that we're going to do is we're going to identify our reference angles. Okay, so that's this guy here, right? And then from there, we're going to label our sides. Okay, so what do I mean by label sides? Opposite, adjacent, and hypotenuse is what I mean. Now, to kind of make things a little bit easier for the next step, my advice is to only label the sides that you care about. And we care about two of them, okay? We care about this side because that's the one that's we're trying to find. So what is that? That's the hypotenuse, right? And we care about this one because that's the one that they gave us. So you're only going to care about two sides at a time, okay? So I'm not going to worry about the adjacent side right now. Just say, okay, hypotenuse and opposite. Those are the only two sides I care about. Okay, so based on the sides we want and have, so I'm going to stop there and I'll say that again. Based on the side that we want and have. So in other words, based on the hypotenuse and opposite, we're going to make a choice about what trig ratio to set up. Okay? So you're going to have three options. Technically there's 6, but we don't need all 6. We just need 3 options. Option 1 is this. Okay. Option 2 is this. And option 3 is this. So I'll wait a second when you guys are writing that down. Before we go any further, let's make sure we're all up to par here. So identify your reference angle. You can't do the next step unless you do that, right? Because how you label those sides depends on what angle is your reference angle. So identify your reference angle, then label your sides, opposite, adjacent. And once again, I recommend only doing the 2 that you care about, the one you want and the one you have. And so based on the side you want, X, and the side you have, 5, you're going to pick one of these. Now, how do you know which one to pick? Well, you're going to pick the one that has the side you want and the side you have. So the side I want is opposite, and the side I have, the side I have is opposite, and the side that I want is hypotenuse. Which of these ratios has opposite and hypotenuse in it? Sine. So that means we're going to use this one in this case. Okay? So after you have identified which trig ratio you're going to use, you're going to plug in stuff. Okay, so for instance, we know we're using this. You're going to have 3 blanks to fill in. Your reference angle goes here. What was my reference angle? 30. And what was my, opposite was 5, and then x went here, right? Now the 5th thing you're going to do is you're going to solve. And at that point you should be able to find that, that side of the triangle. Okay? So, now you don't really need to include the this step here because I'm just giving you guys steps. I was giving an example as we went just so you can kind of understand what I was writing. But there it is. So the hard step there is step 3, which is really just how do you know which formula to use. After that, it's pretty good. And so the trick in that is 2 things. First of all, identify the side you want to have. And then second thing, pick the ratio that has those in it. That's how you know which one to set up. Okay, so let's go ahead and do a quick example, and we'll do a whole example now. So, example 1. The solving step we'll kind of work through also. We didn't get a chance to see that, but so let me go ahead and throw a triangle up here. Put a number here, and I'll put an X right here, and I'll put my reference angle right here, and I'll call that 20 degrees. Okay. Now in the last problem, you guys, since that was a 30-degree angle, we didn't need to solve for X in that way anyway, right? Because we have 30, 60, 90 right triangles. We can already find those sides without using the trig ratios. This one we have to use trig ratios because we don't know what the sides of a 30 or a 20, 90, and that other one would be 70 right triangle is. So here we go. So step 1, what's my, and there's not much to write for the first few steps. So what's my reference angle? It's 20. And we want to label the 2 sides, the one that we want and the one we have. What's the one that I want? Yes. Now is that opposite, adjacent, or hypotenuse? That's the adjacent side. And what's the one that I have? Excuse me, it's the hypotenuse, you're right. So, I want the adjacent, I have the hypotenuse. Now we're going to pick which of those 3 formulas we want. Now you guys have them written down. Which one of those 3 formulas is the one I should pick? Cosine, because it's adjacent and hypotenuse, and that's the one with the A and the H in it, right? So now we're going to set it up. That's step 4, let's plug in our stuff. You got 3 things to plug in. So what goes here? 20 here and here. All right. From here on out, it's a calculator problem. Just as a fair warning, if you guys try to use these yellow calculators, these are set on radians for my calculus class. We do everything in radians. So if you type in 20, it's going to think 20 radians, and you're going to get a very different answer. The blue ones can be set on radians, but they don't need to be. And you can usually tell because on the screen it'll say at the bottom DEG for degrees. But if you see a little phrase on there that says RAD, that means you're working with radians. Your phones can also do this. So let's go ahead and calculate what cosine of 20 is. If you're not getting 0.9397, then you're probably on radians, but most calculators are defaulted to degrees. So there's that, right? So the first thing you're going to do is you can use your calculator to do this. Okay. The next thing you're going to do is we want to get x by itself. So in this case, we're going to multiply both sides by 16. Okay? So on this side they cancel, and I'm left with x equals. And if we left our answer on our calculator from the last time we used it, we could just push times 16 now. And we should be getting 15.035, and we'll just round to the thousandth place for now. And so, if you have a triangle with a hypotenuse of 16 and an angle of 20, then the adjacent side would have to be 15.035. Okay? So that is that. I'm not going to do another example because I don't want to belabor this. It seems like you guys are probably okay with this anyway from what I'm observing. But just so you guys know, you could have a setup that's more like this. So like let's say you have 0.5 equals 6 over x. Okay, so let's say you're at this point and you need to solve. What would you do to solve this? Multiply the x, right? Just like in the last part, we multiplied both sides by the denominator. The only downside is that by doing this, you need to do another step to finish, but that's okay. That's just how it works. So we have 0.5 being multiplied by x now, right? And now what do you have to do? Divide. So the only difference is if you have x in the bottom, you have 2 steps to get it solved. You have to multiply the x first and then divide the number that it's next to after that. If x is on the top, it's really just 1 step. You just multiply that one number in the denominator on both sides and you're good to go. So there's that. Any questions before I throw in at y'all? Alright, so I'm going to give you guys 2 to try. There's one there. There's one there. Alright, try both of those real quick. Alright, so I want to move on to the next half of our lesson today. The next half is you can also use this process to find missing angles, but before we get to that, we have to talk about something here. So inverse trig functions. Let's talk about those for a second. So a really common mistake that I guess it just looks like it, and so people don't really understand what it means. But like, for instance, when I write, don't write this, but I just want to write this up here real quick. When I write this, you know, a lot of students will say when I ask them to read that to me, that they'll say sine times 15. Okay, so that's inaccurate because sine is not a number. It's actually a function. Okay, so you're not multiplying sine by 55 here. What you're doing is you have this function and you're plugging 55 into it, and it's doing something to it. And what it's doing is basically it's calculating ratios on the side of a right triangle. Okay, so that's what it does. Now, so what I want you guys to understand is that sine, cosine, and tangent, they're operations. Just like addition is an operation, subtraction is an operation, division is an operation. Sine is an operation. It's doing something to the number to give you an output. Okay? Just like addition does something to 2 numbers to give you an output, right? And since it's an operation, there are opposites of it as well. So, for instance, if I give you guys this, and I ask you to solve, we want to get x by itself, right? So we do the opposite. Okay? So the opposite of adding 5 is subtracting 5. Or if I gave you this, in this case the 5 is multiplying the x, right? So the opposite is to divide the 5. Those are inverse operations. They're opposites. So we do the opposite to cancel that number off this side, but whatever you do to one side, you have to do to the other. Okay? So that's how we solve for x, is we do inverse operations to get x by itself, and that's how we solve for x. Well, what about this? What if I said sine of x equals 1/2? Okay, what's the angle that would do that? What angle would do that? Now, we could actually do this one. I think I picked this on purpose. Sine is what over what, you guys? Opposite over hypotenuse, right? So if I draw a triangle right now, don't write this once again. You can. I might, there's probably a few homework questions I ask you to do this, but it's not like a standard question I'm going to expect you to know how to do on a test or something. So, but anyway, so if I draw a triangle, x represents an angle, right? So I'm going to put an x right here. Now that's telling me my opposite side is 1, and my hypotenuse is what? 2. Okay, so for this triangle, if this side over here is 1 and this one is 2, what kind of a triangle is that? What kind of a triangle has a hypotenuse that's exactly twice as big as the other side? You're in the right direction, but it's the other one. It's a 30, 60, 90. Okay, I didn't draw the triangle very well. Maybe if I had put it here, it would have made more sense. So it's drawn to scale, so to speak. So if I drew that, right? So now the hypotenuse is twice as long as this leg over here. Well, the only triangle that does that is a 30, 60, 90 right triangle. So that means that this angle would have to be 30. So in some rare circumstances, you can actually work backwards just using geometry, but that's pretty rare. Okay? It just so happens that we know about the sides of a 30, 60, 90. We also just so happen to know the sides of 45, 45, 90s. But we want a strategy that's going to work for any triangle. And that's where inverse trig ratios are going to come in really handy. So let's talk about that. So we talked about how sine is an operation on x. And I want to get x by itself. So to get rid of the sine, I need to do the opposite of sine. Now the opposite of sine is something that looks like this. Has a little -1 right there. And so when you do sine with its opposite, they cancel each other out, right? But whatever you do to one side, you have to do to the other. So on your calculators or phones, your phone should be able to do this as well. Real quick, I want you guys to push second. Do they call it second on the phones? What do they call it on the phone? Shift?
I don't think there's any. It just kind of shows every small.
Really?
Yeah, there's no second.
Can I see?
So to this side.
Yeah, there's a second right there in the top left. Yeah, there's a second button. If you look top left there, you see it? So push second, and what that does is it changes all your buttons from being sine and cosine and tangent to the opposite of sine, the opposite of cosine, the opposite of tangent. So go ahead and I think on your phones though you have to push the number first. So, but here's what we have. We want to calculate this, right? The opposite of sine with on a half there. So I think on your phones you have to put half first. So let's type 0.5 first. Sorry, we shouldn't have pushed second yet. So clear your calculator. Type 0.5 for a half. Okay, now push second. And then sine with a little -1. And what do you get? You should get 30, just like I showed you with the geometry. Yeah.
So you put 0.5 before sine?
So if you're using my calculators, you're going to enter this first. But if you're using your phones, they almost always want you to put the number first. So it just depends on what tool you're using.
So if you use the calculator the same way we're using the phone, it's going to give us a different answer?
It might say error or something like that, or it might give you 0 as an answer. So yeah, it could give you a false answer if you do it backwards. So that make sure you understand both. Because on the test you have to be able to use this, but I know at home it's kind of nice to be able to use your cell phone. So it's kind of nice to know how to use both tools. All right, so let's go ahead and take some notes then on inverse trig ratios. So, the first one is called arc sine. Arc sine. It's also written like this. Okay, and it's the opposite of sine. Okay. We're going to come back to these a little bit later and go into a little bit more depth on these, but for now, this is good enough. The next one we're going to learn here is arc cosine, which is written like this. And it's the opposite of cosine. It's really kind of obvious based on how they're named, which one goes with which, right? And then we have arctangent. Now, technically, yes, there are arcs for the other three that we have, but they're kind of not necessary. Now I want you guys to not get these ideas mixed up. I said it's the opposite of sine. I guess a more formal word, but with more letters, so I didn't want to write it. It's the inverse of sine. Okay? Now, that's different than the reciprocal of sine. Okay? Well, which we know. What is the reciprocal of sine called? Anybody remember that one? I heard a few of you guys saying it. What is it? What's the opposite of sine? Cosecant. So, did I say opposite of sine? I just screwed up. What is the reciprocal of sine? It's cosecant. But the inverse of sine is arc sine. Those are different ideas. Okay, cosecant is just where you flip the fraction over. That's a whole different thing than actually doing the opposite of sine, the inverse of sine. Those are totally different things. Easy to get your minds mixed up with them. Especially when you're using vague words like opposite. But all right, so we use these to find missing angles. So in the beginning of class today, we're using sine, cosine, and tangent, and we use those to find missing sides. Well, you use the inverse trig functions to find missing angles. Okay?
We use what to find angles?
The inverse trig functions, which are those three things: arc sine, arc cosine, and arc tangent. And I abbreviated this, but there's the whole word. So we use these to find missing angles. All right, so let's do our last example for the day, and we'll follow it up with a student practice, and that'll be it. So, example 2. So I'm going to give us a triangle. I'm going to put an angle here, and I'm going to give us two sides. So let's say that this is 10 and this is 8. Okay? Now, if you have a right triangle where both legs are 10 and 8, then that angle has to equal something. It doesn't have a choice. If those two sides are 10 and 8, then that angle will specifically be one thing, and that's what we're going to find. Because like I said, in trigonometry, there's a relationship between the angles and sides of a triangle. Which, by the way, that relationship is not so solid with other shapes, like a square. You could have a square with these shapes, right? You could flex a square, and the sides wouldn't change their size, would they? You could just like make it long like a diamond. So you'd be changing the angles, but not the sides. But with a triangle, the sides are determined by the angles, and therefore it's not changeable. And that's why triangles are very useful in architecture. They're very sturdy, strong. They don't flex, right? Because of that solid relationship between angles and sides. And that's why we care about trigonometry. All right, so here we go. So same steps as last time. What's my reference angle? It's x. So step 1, identify your reference angle. Step 2, label the sides that you care about. Now I'm changing the language here a little bit. Instead of saying label the side you want and have, we actually just have 2 sides that we have. So we're going to label the 2 sides that we have. So what's this one? And what's this one? Adjacent. So opposite and adjacent. And so which trig ratio is concerned with opposite and adjacent? Tangent. So now we're going to set up our equation here. And what goes inside the parentheses? X does. The angle. See, last time we had a number going there. But now we've got an x inside the tangent function there. And over here we have opposite over adjacent. Okay, so for these ones, it looks uglier, but it's actually a little bit easier on the math side for solving it. We want to get rid of tangent. So what we're going to do is we're going to arctan both sides. We're going to arctan both sides. In other words, we're going to do the opposite of tangent so that we can cancel tangent out and get rid of it. Now, you don't really need to show this step if you don't want in the future. But anyway, these cancel out, right? And we have x equals this. So you don't really need to show this middle step. You really could just jump from here to here. All you have to do is take the tangent off this side and put arctan on the other side. Okay? So you don't need to show that middle step. But I like to do it for the first time on our notes just so we know what happened. But this is what we're going to type into our calculator. Okay? So, once again, if you're using cell phones, you're going to do the number first. So do 10 divided by 8. And then second tan. If you're using the blue calculators, you're going to push second tan first and then 10 over 8. Okay? So how many of you guys are using, I'll walk you guys through it more slowly. So for those of you guys with cell phones, follow my lead. Ready? Do 10 divided by 8 first and push equals. And what are we getting? 1.25. Okay. Now push second and then pick the arctan button there. And you should have your answer. Now for those of you guys using my calculator, have a clear screen, push second and then tangent, and you should see a tan with a little -1 now, right? And then you just type in 10 divided by 8 and close your parentheses. Either way though, you should be getting the same answer, which is, yep, and those are degrees, right? So if you have a right triangle with a 10 here and an 8 here, this angle right here would have to be 51.34 degrees. Okay? And that's that. So I'll throw one of them at you, and then we'll call it a day. We'll probably be done a little earlier than usual today. Okay. Okay, guys, so there's your initial setup. It's a sine, and it would be 12 over 20. Then when you arc sine both sides, you'd get arc sine of 12 over 20, which you should end up with about 36.869 degrees there. A lot of times, just so you guys know, on the homework or on the test for this, they say round to the nearest degree. So we would just say 37 degrees. But for some reason on the software I use when it comes to finding side lengths, they usually round it to like, I forget, but there's decimals involved. So that's it, guys. So we're done for today, and we now know how to solve triangles.